Okay, so here we go. So we don't have anything on the screen. Here we go. Let's talk about these terms. So geometric sequences today. They want me to find a sub 1. So there's 36 questions. We're not going to make it through, but I'm going to do what I can and still not go too fast and make sense out of it. So, all right, we'll see what we can do. So a sub 1, they just want you to plug in 1 there. So that'd be 4 to the 1, which is 4, right? We good there? And then plug in 2, which is 4 to the 2nd, better known as 16. And then plug in 3, which is 4 to the 3rd, 64. And a sub 4, plug in 4. 4 to the 4th, is that 256? Okay, on the calculators. And then they're asking, what's the common ratio? What's a ratio?
Something is something.
Something over something, huh? Dividing, right? Ratio means one thing divided by the other. So the way you find the common ratio is you divide, we're going to do a lot of this today, the second term over the first term. So I grab the second term, put it over the first term. So that's going to be 16 over 4, which is 4, common ratio. Yeah, really, you could take any term divided by the previous, because it's common, it's going to be consistent. For example, if I took 64 over 16, you divide those in your calculator, still going to get 4. Yeah, so it's just the common ratio. It's what's commonly happening between the terms. In other words, what's really happening from term to term here? How does 4 become 16, and how does 16 become 64, and 64 become 256? What's happening there? Yeah, they're timesing by 4, aren't they? They're going times 4, times 4, times, well, I'm not writing that very neatly. Times 4, yeah. Every time it's multiplying by 4. So that's the common ratio. They're multiplying by 4 every time. All right. How about number 2? Can you do the same thing on number 2? They're giving you the formula, minus 5, 1/2 to the end. They want you to plug in n equals 1, 2, 3, 4. Can you do that real quick? I'll roll it down when I think everybody's got it copied down. Can you plug in 1, 2, 3, and 4, same thing, and then find the common ratio? For number 2?
Negative 2.5.
They want fractions, I think, on these. So a sub 1 is minus 5/2 to the 1, which is minus 5/2.
Yeah.
Is that good? That 5 whole number goes to the top, doesn't it? You with me? Because it's a whole number. Right? So it goes to the top. Minus 5/2, good. So far, so good. And then when you plug in 2, a sub 2, it's minus 5/2 squared. And so that minus 5 just keeps going to the top, doesn't it? Because it's a whole number. Can you read that okay? Right in between the lines there. Minus 5/4. We good?
I see a pattern developing.
Yes, indeed. And then a sub 3.
And that's negative 5/16.
1/2
Oh, wait, no.
to the 3rd be minus 5/8
Yeah.
on this one.
2, 4, 8. It doubles every time. So the last one.
Yeah, and then the last one,
I think I see something.
a sub 4, minus 5, 1/2 to the 4th,
Makes sense.
minus 5/16.
It's 1/2 every time.
All right, so there's the first four terms. So what's the common ratio?
1/2.
Yeah, so if you could just look at it, great. You know, if you just say, look, what times this guy makes that guy? What's happening every time? It's doubling the denominator, huh? 2, 4, 8, 16. So you're really multiplying by a half, right? Now, if you're not sure, you could always just do it more formally. The ratio is always the second term over the first term. Really, any term divided by the previous term. I'll just grab the second term over the first because they're the easiest two. So minus 5/4 over minus 5/2. And what do you do when you have a fraction on the bottom of a fraction?
You
can do the reciprocal.
Yeah, dividing's upside down, multiplying. So just grab that one on the bottom and you flip it up, huh? So it'd become minus 5/4 times minus 2/5, right? The one on the bottom flips up. These 5's cancel. 2 negatives make positive. 2/4, which reduces to be a half. As we already observed, the common ratio is a half. It's multiplying by a half every time, isn't it? We good on this? It's not starting too bad, right?
Oh, it's going to get worse.
6. They're giving you, they're wanting you to find the fifth term and the nth term. Now at this point I need to give you the formulas. So the A sub n, because they want A sub n, the A sub n formula is A1 times R to the MS1. That's for geometric here in section 12.3. So there's the A sub n geometric formula.
This is the generic geometric, right? Just the
It'll work for anything.
Okay.
Yeah, any geometric sequence. Okay, so, all right, now, what is this A? This is weird. I don't know why they did this. They should have said A1. That's really A1. How do I know? Right here. Whose initial term A? So they're calling it A. I just think that's confusing. I don't know why they do that. It's A1. And in a minute, they'll call it A1 in the next problem. But on this one, they're calling it A. It's A1. Well, how do I know? It's the initial term. It's the first term. So it's A1. For whatever reason, they just said A, but it's A1, really. So A1 is 3, so we just put that in right here. That's just A1. That's the initial term, the first term. The R is 7, so I'll just put that in to the n minus 1. So there's the A sub n formula, which is actually the second question. Let's go back now and answer the first question. What's A sub 5? Is everybody good to there first off? See how I found A sub n? I just put in the A1, put in the R. Now, to find A sub 5, kind of working backwards,
Yeah, like that.
just plug in the 5, yeah, because the n is 5. 3 times 7 to the 4th. Somebody got that? 7203, my calculator said. 7203. All right, I'll keep. Okay, so, whoops. So there's number 10. So they want the fifth term of that sequence of numbers. 1, let me write it a little bigger for you. 1, comma 1/5, comma 1/25. This is the first term, second term, third term. There's the fourth and the fifth.
Ooh, that's going to be big.
Yeah. So what could we do? I'm not going to use any formulas on this one because it's only 2 jumps away. Right? It's not far away. It's just 2 jumps away.
25 times 25.
Yeah, and see what's happening on the well. What's happening every time? What's going on from term? What happened from here to here? Times 5 in the bottom, or 1/5 overall. Totally right. They're basically just taking 5 and multiplying it on the bottom, or 1/5 overall. Same thing, right? So the next one would be just use your calculator. Just take 25 and go times 5, be 125, and then one more time times 5. 1/625, done. So I'm not going to use any formula or do anything fancy like that. Does that make sense? I think that's easier. Just do it that way. I think the help button would show using a formula and stuff. But let's do that. Want to do the same thing on number 11? They just want the seventh term. See how it starts off 2, then negative 8, then 32. This is the first, second, third. Can you find the fourth, fifth, sixth, and seventh? So they just want you to go out to the seventh term. Can you do that? Just go to the seventh term real quick.
-1 times 4 to the n.
Is that what it is? You getting the
I
formula?
don't I'm trying to remember.
All right, so what's happening as 2 becomes, how do you make 2 into negative 8? 2 times what is negative 8? Yeah, times negative 4. And then times negative 4. See how it's just multiplying by negative 4 every time? That's what's making the sign switch back and forth. It's just multiplying by negative 4 every time, isn't it?
How did we do it last time?
So the difference between this section and the last one is this time we're multiplying from term to term. The last section was arithmetic. We were adding and subtracting, right? Remember I said arithmetic. So last night's homework 12.2 was arithmetic, sequences and series. And so arithmetic is adding, subtracting. You were adding the same number or subtracting the same number. Now we're multiplying the same number. Or you could say dividing if you multiply by, like this one, we multiplied by a fifth, which is really dividing by 5. So yeah, we're multiplying or dividing now. That's what's new in this section. It's the same as the last section, but now we're multiplying or dividing, however you want to say it, from term to term.
How do
So,
we alternate negatives and positives?
because we're multiplying by a negative number. So if you keep multiplying by a negative number, it'll keep switching signs.
Oh, okay.
So multiply by negative 4, you get negative, is that 128?
Yeah.
And then you go times negative 4 again,
512.
positive 512, and then you go times negative 4, negative 248,
And then 81 negative.
and then one more time, times negative 4, positive 8,000, what is it?
8192.
8192?
Yeah.
Thank you. Positive 8192. Does that make sense? Just use your calculator or your friend and just multiply by negative 4 every time until you get there. All right. You guys okay with that? I want to get to the hard ones, but I don't want to go so fast I'm not making any sense. Is that all good? Okay. So there's number 14. Now they want me to write a formula, an a sub n formula. So how do we do that? Well, we've got to remember the a sub n formula. Let me write it down for you again. The a sub n formula for geometry. So on the test, say this was on the test in a couple weeks, you would say, okay, geometric a sub n formula, what is it? It is, you'd have it written on your 3x5 card, right? It's a1 times r to the n minus 1. a1 times r to the n minus 1. So let's give it a go. What's a1?
It's -1.
Yeah, a1 means first term. Yeah, so just -1. We good so far? a1 always means first term in any sequence. So that's -1.
R is 1/4.
Hold on. Oops, come on.
What is R -1/4?
Not writing very well. Yeah, so yeah, to figure out R. Remember how we learned to figure out R? How do you always figure out R? The common ratio. If you're not sure, you can try just looking at it. That's good if you can do that. If you're at all unsure, remember it's always any term divided by the previous term. I always do second over first. So the second term divided by the first term gives you the common ratio. So 1/4 divided by -1 is just -1/4, huh? So the common ratio is -1/4. So the R, so here's a1, R is now -1/4 to the n minus 1. We're done. They want a -1 here. They want a -1/4 there. We got the formula. Is that okay? So you'd have that formula on your 3x5 card. And it says geometric. And you would write next to it geometric on your 3x5 card. All right. Well, yeah, try 15. I'll just leave it on the screen. 15, they're being more tricky. They're giving you the 7th term and the R, and they want you to find the A sub n formula. So now, this is definitely a curveball. It's not normal. It's a weird situation. See if you can find A sub n.
So we're looking for n, right?
So I would first write out the A sub n formula, since that's what you're trying to find. What is the A sub n formula? It's A1 times R to the n minus 1.
I'm thinking if we put A7 in for 8n, and then do,
So there's the formula. So what do we really need to find then? If they want me to find the formula, which is what they want A sub n, what does that mean I really need to find? A1 and R. And the n minus 1 will just be part of the formula. So I need A1 and R. That's what it's all about. Got R. No mystery there. So what do I really need? A1. So really, this problem boils down to get your hands on A1. Let me go to a fresh screen here. So number 15, make it a little more room. So A7 is 4096. And R is negative 4. So here's what I would suggest. 3, 4, 5, 6, 7. So the 7th term we know is 4096. The first term is what we want back here, right? Guys with me? Because we need the A sub n formula. The A sub n formula is A1 times R to the n minus 1.
Right.
I know what R is. R's negative 4. So it's all about find A1. So anybody have a good thought? How can we're at the 7th term, how do we get back to the first term?
I just wrote 1 times negative 1/4.
Good idea. So Rachel, what'd you do?
I took 1, started by 1, and then times it by negative 4.
Oh, you started with 1?
Yeah.
You just randomly guessed at 1? That's good
It
guessing.
worked out.
Yeah, that was really... Okay, let's suppose you're not such a good guesser as Rachel is. How could we start from the 4096 and work our way back?
So the
Divide by
difference is
negative.
7/4.
Yeah, because remember what the R means. Maybe I haven't made this clear. I'm kind of flying along through these quickly, probably too quickly in some ways. That's the number you multiply by every time, right? Look at any of these sequences, like this sequence right here. Here you're multiplying by negative 1/4, multiplying by negative 1/4. Huh? In all these sequences, whatever the R is, that's what's causing the jump every time. That's what you're multiplying by. So this is, you go from here to here times negative 4, and you go from here to here times negative 4, etc. So you go forward in the list multiplying by negative 4. So how are you going to go backwards in the list? Divide by negative 4. Because that's the opposite, of multiplying by negative 4. So if you take 4096 and you divide by negative 4, you get, I don't know.
You get negative 10/24.
No, it is, thank you. You get negative 1024. So do y'all see what I just did there? When they give you the R, they're giving you what you multiply by to go forward or divide by to go backwards. That's what geometric sequences are. The number you multiply from term to term. So to go backwards, you divide. Right? This making sense? Keep going, then divide by negative 4 again. Positive, regular 256. And then divide again, negative. So just keep dividing by negative 4. Keep dividing by negative 4. Positive 16. Again, go backwards. 2 more steps. We're almost there. It's going to be -4. And one more time. -4 divided by -4?
6.
+1. There we go. So the a sub n formula is 1 times -4 to the n minus 1.
Can we do it the other way?
What other way?
Like they gave us an n a7.
Right.
-1, 6. I did this way. They gave me this.
Go ahead.
7.
Keep going. 7 minus 1, 6.
Yeah, a1's multiple -4 over 6.
Like that, right?
Mm-hmm.
Yeah. Good thinking. Good thinking, Abdul. Yeah, so what Abdul's doing is he's basically using the formula. That's a great way to go. He's basically using the formula, and he's saying, look, the formula says that you just take A1 times R to the n, right? And he's saying A1, R, we know R is -4. And the n, what's the n? Well, we know the 7th term, n7, comes out 4096. Solve that equation for A1.
To the n minus 1 would be n plus 6.
Oh, it's supposed to be n minus 1. You're right. And that should be 7 minus 1, 6. Yeah, so then, yep, good job. That'll work also. Well done.
That's what I was thinking.
Good on that. So by formula or by just stepping backwards, either way, you can get A1, and we get the formula. 16, they're giving you the second term and the fourth term, and they want the formula. Remember, the formula is A sub n is
That's quite a jump.
A1 times R to the n minus 1. So imagine 4 terms here. A1, A2, A3, A4. They give me the second term is 9. The fourth term is 3249. All right, so they're giving you the second and the fourth, and somehow you want to find A1 and R so that you'll have the formula. So how can we do it? How can we find A1 and R? Give you a second.
Takes A4 divided by A2.
No.
Right?
Take A4 divided by A2. It's any term over the immediate preceding term
No.
would be R.
Oh.
You have to have the third term over the second term.
Oh, okay.
Any ideas on R?
No.
Be good to find R first.
Can we put the fourth term under the second term, but then we multiply the second term twice?
Multiply second term twice. So we don't multiply the term, we multiply the R to jump from term to term. Right? Like whatever R is, you see it's what you times by every time. So in other words, times R. And this one, to go from there to there, you go times R. To go from here to here, you go times R, etc. So every time we're multiplying by R, aren't we? Does that make sense? That's what the R is. It's what's causing the jump. You multiply by R, multiply by R, multiply by R.
I don't think that would work either.
Any ideas?
No.
I was thinking you could plug in A4.
How do we get from the second term to the fourth term? What do we do?
Multiply
You're
by something.
multiplying it by the R.
You take 9, the second term, and you multiply it by R, and then you get this term,
So equals.
which I don't know,
So
Multiply
equals.
by
and then
9r squared.
multiply by another R, and you get 3249, don't you?
So make that a thing.
Don't you multiply by R twice? In other words, 9R squared.
Divide by
Was that what you were doing, Abdul?
Divide by
I
9.
did the move.
Does that make sense? 9 times R is 3249, isn't it? It's just R twice multiplied. R squared. That makes sense. Remember, R is what jumps you from term to term.
19. Oh, wait.
So now we solve for R. Divide by 9. So we get R squared. Is that 361?
Uh-huh.
Yeah.
And then last step to get regular R?
Root it.
Root it.
Um,
R is 19.
oh, that's just a difference. Okay.
So R is 19. We good? We got R is 19. So that's right here. That's 19.
So the first term would be negative 10? No, couldn't be.
So our formula now becomes, I'll put this in. This is A1 times 19 to the n minus 1. Our R is 19, right? Now all we need is A1. How are we doing? This making sense so far?
So,
That good?
5, 9,
How do we get A1?
That's, I don't think that's right.
How do we get A1?
Go all the way back to.
So,
Yeah.
so 9 by,
9 over 19.
Yeah, so how do I
by 19.
That's what I had.
how do I go backwards from the 9 back to the A1?
You divide,
Elise's plan is good. How do I do it? How do I go backwards?
divide by the, so 19.
Yeah, remember going forward you multiply by the R, going backward you divide by the R. So we take 9 and we divide by the R of 19. Must be 9 over 19, huh? Does that make sense? Because if you went forward, 9 over 19 times 19, the 19s would cancel and you'd get 9, wouldn't you? Does that make sense? So remember, the R is the number you're multiplying by every time as you go forward, dividing by as you go backwards. So the A1 right here is 9 over 19. We're done. We got the formula. How we doing? Is that good?
So now we're on the SN.
Is that confusing? Are we okay there? Did I do that too quickly? Am I making sense? So as you go forward, you multiply by R every time. As you go backward, you divide by R. All right. Let's move on to number 17. Yeah, now we're shifting to a new formula for number 17. Why? Because we're doing sum. They're being added. So notice they're being added up now. So we go to a new formula. Here it is. S sub n is A1 times 1 minus R to the n over 1 minus R. There's our S sub n formula. So we want to use that formula, plug in A1, plug in R, and then we're going to have to clean it up a little bit. So see if you can find A1. See if you can find R. What's A1? 1/5, first term, huh? A1 just means first term. And then how do we always find R?
By simple observation.
By clear observation.
Subtract.
How do we always find R? We've been doing it 5 or 6 times already.
Isn't it a whole number too?
Second term divided by first term, right? Or any term divided by the previous term. R is just what you're multiplying by every time. Well, you tell me, or you can just look, maybe. What are you multiplying by every time? Is the 5 on the bottom changing? No, that's just always there. We're not multiplying by that. That's just always been there.
That's 2.
So what are we multiplying by every time?
2.
2. The top by 2. 2. Huh. The R is 2, isn't it? Do you see that? But if you're not sure, just take the second term over the first term. I'm going to go to fresh screen and do that. Yeah, so the S sub n formula down here is a 1 minus r to the n over 1 minus r. Yeah, the r is the second term over the first term. So you can grab the second term over the first. It's a common ratio. It's what you're multiplying by every time. It's going to come out 2. But if you're not sure, you can just take second term over first term. Remember what when you have a fraction over a fraction? Dividing is upside down, multiplying. Yeah, so just flip it up. The bottom flips up. 5 over 1 cancels. 2 over 1, 2. Like we observed, the r is 2. Okay, and the a1, that's just the first term, 1/5. So it's 1/5 times 1 minus 2 to the n over 1 minus 2. We good there? Mm-hmm. Now, we can't leave it that way. They want us to do some cleanup. How do I know? Look at the form of the answer they want right here. Do you see what they're wanting? They're wanting something in the front times something to the n minus 1 at the back. Mm-hmm. So that's a little bit of cleanup. So let's do some algebra cleanup. How can we start cleaning this thing up to make it look like that?
1 minus 2 on the bottom.
Whoops. Yeah, absolutely. 1 minus 2 on the bottom. Negative 1. All right. So, so we got, that's negative 1. Good idea. And then, what else can we do?
Negative 1 over 3rd.
Yeah, let's just multiply those denominators, huh? Just, these guys will just multiply. So we'll get, oops. These guys will give us, see, it's just not writing well. I think I need that new tip. All right, so 1 over negative 5, is that good? Times. Oh, you know what?
Huh?
Yeah, what you said's a good idea, but
You just multiply straight across.
let me show you what they're doing. I'm not going to do that just because they did a certain thing. In general, that's a good thing to do, but they did a really specific thing. Let me show you. Here's what I'm going to do. This bottom right here, as we said, is negative 1, huh? Mm-hmm. So what I'm going to do is I'm going to take their thing and I'm going to put 1 over negative 1 minus the 2 to the n over negative 1.
And distribute.
See what I did there? So the bottom is negative 1. 1 minus 2 is negative 1. And then this is a fraction, right? I'm going to put both these guys separately over the negative 1. Why am I even doing that? Because I'm looking up here and I'm noticing they've turned things around somehow. See? In the parentheses, they've got the n thing coming first and the minus 1 at the back. I have the 1 in the front. Well, they've turned things around. This is what will do that. So this is, what's 1 over minus 1? Negative 1. And right here, 2 negatives, positive, and that's just 2 to the n. And finally, 2 to the n. Well, there's the form they want. See? 2 to the n. This is 1/5. Done. Everybody see that? You okay with those last steps? That's a little algebra manipulation there. So we add a fraction over negative 1. I put that negative 1 under each one. Right, that's just common denominator split up there. And then that's negative 1 and 2 negatives makes positive. And then you can change the order on these guys, right? Because you can switch the order and things all you want as long as you keep the sign in the front with it. The positive still in front of the 2n, right? There's nothing in front, which is positive. The negative still in front of the 1, so that's fine. You can switch the order as long as you keep the sign in the front the same. So that's right, and that's what they did. So that was kind of a pain. We had to make it look like theirs. They'll do that on like this problem and one more. I think the next one. Well, we got to do that. All right, I'll move on. You okay? Okay, remember summation notation, the big Greek S? That means sum, add them up. So what you should start is just get the first couple terms. You guys tracking with me? So in other words, let K be 1, let K be 2. So plug in 1. You get 4/5 to the 1 plus plug in 2, 4/5 to the 2 plus dot, dot, dot. What's the last one? Remember how these summation notations work? Start at 1, end it in, huh? It's going to be
A sub 1 is
4/5 to the n. Is that good? See how that works? Start at 1, go to n. So you want to add those up. So write down the S sub n formula. Now the S sub n formula. S sub n, A1, 1 minus r to the n over 1 minus r. So plug in A1. What's A1?
4/5.
Yes, first term, right? A1's first term, 4/5. And then figure out what R is. Remember how we can always find R?
It's 4/5, isn't it? 'Cause you just
It
times
is.
4/5.
Second term over first term, 4/5. We good? How y'all doing?
So you're gonna end up
R
with
is
4/5 times 1 minus
second term, so, oops, I'm running out of room there. I'm going to have to go to a fresh screen here, but R is second term over first term, which is 4/5 squared over 4/5, right? You guys okay there? Remember how we find R? So it's second term over first term, second term over first term. And what do you do when you have like same numbers with powers?
Well, that one is an automatic 1, so
This
it's
is-
2 minus 1 is 1.
Subtract powers, huh? Remember that? Remember like 5 to the third over 5 to the first is 5 squared kind of thing? From your algebra day, subtract the powers when the bases are the same and they're divided, you subtract the powers, right? You remember that? So that'll become 4/5 to the 1, or just 4/5, which we knew. You could just look, go, well, it's just timesing by another 4/5 every time. Exactly. So the R is 4/5, and so is the A1. They're both 4/5, aren't they? So I'm going to go to a fresh screen here. So number 18, and it's 4/5 to the 1, 4/5 to the second, dot, 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 4/5 to the n. So the S sub n form, that's what they want, is S sub n, yeah, is A1, 1 minus r to the n over 1 minus r. So it's A1, which is a fifth, and 1 minus r, and r is also a 4. Oh, wait, A1 is 4/5,
Yeah.
and r is 4/5. I'm messing up here.
1 minus 4/5 is 1/5.
Yeah, right.
Doesn't it cancel out? No, it goes to 5.
We good to there so far?
But we're going to have to do the same thing and distribute them.
So yes, okay, so we ready? We're going to clean that. We're doing some algebra cleanup now. But is everybody okay to there first? I want to make sure you're with me before we dive into the mess. Won't be too bad, but it'll be a couple steps. Everybody okay to there? We see what we did. So I just put in A1. A1 is the first term, and we found R is 4/5 also. Okay, now, how do we clean up that bottom? What is 1 minus 4/5? Yeah, is everybody good? That's just 1/5, isn't it? Like 1 whole pie, take away 4/5 of the pie, leaves you 1/5 of the pie. Right? Just being real there. This is 5/5 minus 4/5. Common denominator would be 1/5. All right, so what does that give me? Well, let's bring it over here. S sub n is 4/5 times 1 minus 4/5 to the n over, that denominator's become 1/5, right? And what do we do with a fraction on the bottom of a fraction?
Invert and multiply.
We always grab it and flip it up, right? So grab that and flip it up, that 1/5. Now, normally I grab the 1/5 and I flip it up over on the right. But this time, right side, left side doesn't matter. They're just multiplied, so the order of multiplying never matters. It'd be a little more useful to flip it right there because I want it to interact with that 4/5 and have those 5s cancel. Just to make things nice. Does everybody see that? Why I'm going that way? So S sub n will be 4/5 times 5 over 1 times 1 minus 4/5 to the n. Yeah, and so then those 5s will cancel, won't they? And this is just 4.
4 distributes to the 1.
Oh, we'll just leave it. They just want us to leave it, although you're right, we could do that in general. I think this is the look they want. Let me go back and make sure. Yeah, so they want something in the front and then a 1 minus something. And that's what we have. They want it just like that. So we're done. We got to the look they want. I was just moving towards that look. Always want to keep one eye on the goal as you're moving through those. Did you have one eye on the goal? All right, we good there? I had one eye for you on the goal there. Questions? Because we're halfway through now. What was number 18 out of 36? We're halfway. We have an hour to go. Good, we're on track. All right, yeah. So I'm going to use the formula and just use my graphic calculator at the end. So go ahead and use the same form. What formula am I going to use? They're being added up, so you're going to use the S sub n for sum. Do you guys see how you're going to know which formula to use on the exam in a couple weeks? When they're being summed, when they're being added up, you use the S sub n formula. Right? So use that formula, plug in, and once you get all the numbers in there, just hit the buttons on your calculator and get the answer. But it's easier said than done. This is kind of a tricky one. Especially n is tricky. This one's a decimal answer. See, all these answers are calculator. Or we'll get an actual decimal this time, not just like a formula. All right, so let me jump in with you. What's A1?
1/8.
First term, huh? Always a first term. So S sub n is 1/8
N equals 13.
times. Now, what is R?
7.
Good, yeah. Do you see what's happening from term to term there? It's just multiplying the top by another 7. The 8 on the bottom's not changing. That's always been there. Yeah, if you're not sure, remember how you can do R. I'll do it somewhere over here. If you can't tell, then you can always formally say, well, R is second term over first term. It's 7/8 over 1/8, right? Second term over first term. Flip that 1/8 up. R is 7/8 times 8 over 1. 8's cancel. Sure enough, R is 7 as we observed. R is 7. Okay. So then we'll go back to 1 minus R to the n over 1 minus R. Good so far? So we got the A1, 1/8. We got the R is 7. We plugged everything in, but we don't have n yet. That's the tricky part. So n, what is n? N is number of terms, right? In all of our formulas. The ones we did last time, the ones today, it's always the same thing. N is always the number of terms. How many terms are there? So, how many terms are there? Be careful, it's tricky. It's going to 11, right. But if I go to 11 and I start at 6,
That's not 11.
that wouldn't be 11. If I start at 1, that's 11. If I start at 0 and I go to 11, how many terms you got?
It's like an index.
One more than 11. 12. Right. So where does the 1 start? Here's what you want to do. Identify the power of 1. That's where you want to start. Where's that?
7.
Right there. This from here to here must be 11 terms. So how many must there be total? Boy, my pen's not writing. Come on, pen. Trying to get something done here. This must be 11 terms. Right? From here to here. Because starting at 1, so whenever you identify where the 1 is, from there to the end, you've got that many, and then this is an extra term. This is the 12th term. There must be 12 terms, huh? Does everybody see that? See why that is? So identify here's where the 1 power is. That from there to the 11 is 11 terms, but there's a term before that. So there must be 12 terms.
The total would be n.
N would be 12, exactly. So n is 12. We got to plug in 12 for n. Is that good there? So now you could hit the buttons on your calculator. I would do a step of cleanup. You don't have to, though. If you're really good with the calculator, you could do it all from there. Here's what I would think would make things easier for you on the calculator. What's that denominator? What's 1 minus 7? Minus 6. Right? Just make that negative 6. And I would even multiply those two denominators together to get
1 over
negative 48. Come on. Then I would hit the buttons. That's just easier at that point. I'm getting 288 288,360 150. So, okay. Did you guys get that okay?
Yeah.
So that is, notice they wrote them all in scientific notation, didn't they? 2.88 times 10 to what power?
No, 8.
So
10 to 8.
So they put the decimal point after the 2. So if you put it after the 2, how many to get back to the end of the number? 1, 2, 3, 4, 5, 6, 7, 8, 10 to the 8. Does everybody see that? You need an 8 power to get back to the end of the number. That's 2.88 times 10 to the 8, isn't it? All right, that was a hard one. We good with that? Yeah, Elise.
When you put in SN equals 1/8, isn't A1 supposed to be 7 over 8?
No, A1 is the first term.
It's always the first.
It's always the very first term. It doesn't matter like where the 1 power is or any of that other kind of stuff. A1 literally means, good question, it's the very first term. On that. Yep, so that's the 1/8. Good, other questions on that one? All right, you want to try one of those? Try 21.
Summation. Wow, that's so cool. I'm just gonna do that.
But this is on that part where you can't use it on the test. Oh, this was crap.
Yeah, I will actually ask to see the steps on this one, but it's fun to have a good thing to check with.
I don't even know how to use
So
it.
maybe like on the test we would have this like the non-calculator part or something like that.
What I'll do is I'll put it on the calculator part because it's big numbers, but I'll say I want to see the actual steps. Yeah.
We get first credit for stuff.
Okay, so may as well.
Well, actually, no, it's multiple choice, huh? So I don't see your work. No, I think I give you one like this or something where you have to do it out. I think that's somehow you got to know how to do it with the formula. I think that's what it is. Yeah, you'll see it on the practice exam. All right, so yeah, so whenever they give you that summation notation, list a couple terms. So n equals 1, which would be 3/8, the first term, and n equals 2. Which is 3/8 squared. These are added up, plus plus 3/8 to the 15, right? N equals 15, like that. Okay. And then write the S sub n formula. The S sub n formula is A1 times 1 minus r to the n over 1 minus r. So A1, what's A1? 3/8. 1 minus
3/8.
R. Yeah, what's R?
3/8.
Also 3/8, huh? Because remember, R is always second term over first. Second term is 3/8 squared over first term. 3/8 power subtract, just 3/8, huh? Everybody okay with that?
Yeah.
R is always second term over first. So that's also 3/8. So this will be 3/8
It's 5/8 on
to the n. 1 minus 3/8 down there. Yeah, you could. Oh yeah, what's in? What's in the number of terms? Yeah, that's just straight 15 this time, isn't it? There's just 15 terms. There's no adding one or extra term in the front. As it goes from 1 to 15, that's everything, right? Whereas in the last one, as it went from 1 to 11, there was still an extra one in front. The 12th term, huh? There was a term before the 1 power. This time, the 1 power is the first term. 15, so n is 15. Yeah, so they want a decimal rounded to 3 places. So I would clean up the bottom first. What is 1 minus 3/8 down there in the bottom? 1 whole pi, take away 3/8 of the pi,
5/8 of pi.
leaves 5/8 of the pi. Right, 1 whole pi, take away 3/8 is 5/8. So that bottom is 5/8.
So flip it, cross multiply for its first term.
Yeah, and you can flip that up, right? That 5/8 you can flip up whenever you have a fraction on the bottom. Flip it up.
Is 15?
and flip it up right next to that 3/8. So you'll have 3/8 times 8/5 times 1 minus 3/8 to the 15th. Are we good to there so far? Is that making sense what I'm doing? I grabbed that 1 minus 3/8 is 5/8 on the bottom, flipped it up. These 8s will now cancel. And so I would just use my calculator at that point. I would just go, just the rest on calculator. I'm getting 0.5, and then the 9s just go and go and go and go. They want that rounded to 3 places, so that's going to be 0.600. Rounded to 3 places. We good? All right. Can I move on from that? Questions I can answer?
Can we distribute the 3/5?
Well, it's just all calculator, so you don't need to. You're going to hit the buttons at some point. You could hit the buttons way back here if you don't want to clean up at all. It's just whatever's easiest for you. At any point, you can say, I'm going to hit the buttons for the rest of it. Do you know what I mean? We don't have to make it have any certain look, since in the end they just want a decimal. So at any point you want to stop cleaning up and just hit the buttons, it's fine. I just went a couple steps to make it easier to hit the buttons. But you can do whatever's easiest for you. Because in the end, they just want the decimal. They don't care how you got there. Questions on that one? Hang on. Remember the paper problem? I said for the paper, we were going to throw away the paper. That's a funny looking A there. For the paper problem. So how much of the paper did the robot throw away in the first 10 seconds?
Half a page.
So if you throw away half a page, and then the next 10 seconds, what do you throw away?
1/4.
Fourth of a page. The next 10 seconds?
1/8.
1/8 of a page, etc. For how long?
Ever.
Forever.
4.
Forever, right? We're adding that up. That's piling up in the trash can forever. So what are those going to add up to be forever? Well, we have a formula. Let me get it for you. S sub infinity. So it's the infinity formula, and it's A1 over 1 minus R, but you can't always use it. It's one of these formulas that's only usable in certain situations. Only when R is between -1 and +1. That's when you can get an answer and the series is said to converge. Converge means settles on an answer. When R is not between -1 and +1. When R is not between -1 and +1, the sum diverges, which means it heads off to infinity. Well, it doesn't settle. No finite answer. So this is a tricky formula. It's not hard to use, but you got to remember to only use it when R is between -1 and +1. This is R between -1 and +1.
Okay. So if our answer falls in between -1 and +1, it converges.
Yep, it converges. It converges if R is between -1 and +1. Converges means has a finite answer.
Correct.
But if R is not between -1 and +1, then the sum diverges. No finite answer. So, All right, so let's look at our little paper example that we were talking about. Throwing paper in the trash. Throw half the paper in the trash the first 10 seconds, then a fourth of the paper, then an eighth of the paper, etc. So how much paper will be in the trash after forever? So, well, it says it's, first off, what's our R? What's happening from term to term here? What's it multiplying by? A half. It's going times a half. The denominator's being multiplied by 2. It's times a half. That's our R value. You guys with me on that? R, remember, is always the second term over the first, if you want to double check. Second term over first, it's 1/4 over a half. Grab this denominator, flip it up. So it's a fourth times 2 over 1. 2 goes into 4, sure enough, a half. Good there? Am I going too quick? So R is a half. Right? We okay there? 2 goes into 4 2 times. So R is a half. So the first thing is to check, can we use the formula?
Yes.
R is a half is between -1 and +1. Yeah, a half is between -1 and +1, isn't it? So we can use the formula. It converges, so I can use it. S sub infinity will be A1. What's A1?
1.
First term, a half. Over 1 minus R. What's R? Also a half. So what do we get? A half over, what's 1 minus a half? A half. A half over a half is? 1 whole paper. Is that true? Remember I was doing the throw half the paper in the trash, then half of the half, and half of that, 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 and half of that. I thought we never threw away the whole paper. Thought we just got down to a little bitty tiny piece. Why is the answer telling us we throw away one whole paper? Because it's telling us what the answer would be after forever. Even though you can't go there, you can't go after forever, you can figure out what it would be. After forever, the whole paper would be in the trash. Exactly one whole paper would be in the trash. Does that make sense?
After forever?
After forever. Yeah, now we're really getting weird, huh? After forever. That's what an infinite sum is. After adding them forever, well, how can you do that if it's forever? You're still going. It would be one whole paper. That's what we're figuring out.
In the past video, you're offering $100 after forever.
Okay, right. Yeah.
Just
Yeah,
waiting on that.
right. Try that one forever. So what's the formula? So how would you recognize this on the next exam in a couple weeks? You would see the ... and you go, oh, that's the infinity. So write the A1 over 1 minus R, the S sub infinity formula. What's the A1?
Negative
8.
164.
A1 is 8. A1 is the first term. Okay, now we got to find the R. So you know how to find the R, right? Second term divided by first term? That's how we always find R. Second term over first term. What's the second term?
-1/64.
It's negative 1/8 over the first term, which is 8. So second term over first term. How do we simplify that? Remember when we have fractions over fractions? Make the denominator 8 over 1, grab it, and flip it upside down, huh? So it'd be negative 1/8 times 1/8, negative 1/64. So we got our R? Our r is negative 1/64. Be careful in the formula. You're going to have double negatives, right? Do you see that? You got a negative in the formula, and then r is also negative. So when you plug it in, double negative. Oh, by the way, is that r? Is it between?
No.
Is r between -1 and +1? Yeah. It basically isn't a fraction. That's what the numbers between -1 and +1 are. They're fractions. Right? If you imagine a number line, you know what I mean? Here's -1, here's +1, here's 0. Yeah, negative 1/64 is about right there, really close to 0. Just a little to the left, huh? Good. So yeah, it's between -1. So that means you can use the formula. So go ahead and it's going to converge. It's not going to diverge. So you can use the formula. So I'm going to plug in negative 1/64 right there for r. We got the double negative thing. Am I going too quick? Is this okay? Is this making sense? Getting the hang of finding the r. It's always second term over first. So then just do some algebra cleanup here. Easier said than done sometimes. So that's 8 over, and the bottom is 1 plus, right? The double negative becomes positive. And how do you do 1 plus 1/64? Yeah, because 1 is 64/64. So that's 65/64 on the bottom, right? And then, fractions over fractions, grab the denominator, flip it up to the top, so it'll become 8 times 64 over 65. Whole number, put it over 1, multiply, 1, 2, 2, 512 over 65. There it is. Does that make sense? How we doing?
Oh, okay, it's the same thing. I just got decimal.
Got decimal version?
Yeah. I don't like fractions.
Is it 7 point?
7.88 rounded.
Okay. Yeah, I think they want fraction on this one.
7.82.
Yeah, so you got to give them a fraction. I think they're asking for that. We good there? Does that make sense? Questions I can answer. You guys are not looking too thrilled with this. I want to make sure I'm making sense. Is it making sense? Anything I can clarify?
It's just weird.
It's new.
It is weird, isn't it? It's weird that you can add up things forever and get a finite. Okay, so try 26. So sum. So now they're doing the same thing in summation notation. How would you know you need to use the S of infinity formula?
It says infinity.
It's got an infinity. Yeah, right? The ending point's infinity. Remember how the summation symbol works? This is the start. And this is the end. The end is infinity. So you're going to use the S of infinity formula. So crank out a couple terms, plug in 1, plug in 2, plug in 3, so you can get the information you need for the S of infinity formula. Let's see what you can get. So let K be 1. Okay, if you plug in 1, am I going too quick? Go ahead, plug in 1. Right, let K be 1, then let K be 2. Get a couple terms there.
1 minus 1 is 0 is 10. That's fine.
So the first one is 4 times minus 1/3 to the 1 minus 1. Good, I just plugged in 1 here for K. Are we good? Plug in 1 for K. And that's 4 times minus 1/3 to the 0. What's anything to the 0 power?
1.
1. So this is just 4 times 1. This is just 4. So the first term is just 4, isn't it? Very good. And then down here I'll do the second term. K is 2. Can you get the second term? And is that minus 4/3? We good there for the second term? Okay, so that's really all you need, the first term and the second term, because then you can find the R, right? You need the R, which is second term divided by first term.
If you're confident enough, it's whatever's to the power.
Yeah, exactly. So yeah, if you're used to reading these formulas, if you notice the pattern, the R is always going to be the number that's raised to the n or n plus 1. It doesn't matter. In any kind of n thing power, it's the base. So it's going to be minus 1/3. The R is going to be the number that has the letter power on it. It's the minus 1/3. That's true. So if you're not sure, you can do it formally. It's always second term over first. So the second term minus 4/3 over the first term, 4. Right? And remember how I'm just proving it really is minus 1/3. Put this over 1, grab it, flip it up. So that's going to be minus 4/3 times 1 over 4. The 4's cancel. Minus 1/3. So the R is minus 1/3 as we observed. So we've got the first term, second term, the R. Now we're ready to crank out the S sub infinity formula. So what is it? S sub infinity is a 1 over 1 minus R, isn't it? We've got a 1. That's 4. This is a 1 over 1 minus R. Now careful. Positive, because double negative, right? 1 minus 1/3. Double negative. Going to be positive. We good to there? I'm going to go to a fresh screen over here. So what number is this? Number 26. So S sub infinity, a 1, 1 minus R. What was it? 4 over 1 minus 1/3. It's 4 over 1 plus 1/3. So S sub infinity is 4 over 1 is 3/3, isn't it? This is 3/3 plus 1/3 is 4/3. You know what we do when we got fraction over fraction. Grab the one on the bottom, flip it up. And so we're going to get 4 times 3/4. Yeah, this 4 over 1, cancel 3. All that is 3. After forever, that adds up to 3.
Okay. We enter clear method.
That good? Hey, did we check if that was actually okay? What was that R value? Was R was negative 1/3. Is that between negative 1 and positive 1? Yeah, it's good. As long as R is a fraction, it's good. We got it. We good with that?
0.3333.
So that goes to my question. Renee was hinting at my question. You guys know 0.9 bar, right? What's 0.9 bar? Well,
Forever, 0.999.
yeah, you think it, right? You know what a bar means over a decimal?
Yeah, it goes on forever. The same number.
0.9's forever, right? 0.9's forever. What is that close to?
1.
It's pretty close to 1, huh? It's pretty close to 1.0, huh? But it's not exactly 1, is it?
No.
Yes. Yes, it is. I will bet you $20 it is.
Oh, the bet went up from $10 to
Yeah.
$20.
Bet
On the
you
video, it was
not.
10. Oh, it was $100. That's right. I see. Anyway, yeah. So that's the question: is 0.9 0.9's forever close to 1.0 or the same as 1.0?
Apparently it's the same.
Well, let's hold off on that thought. Set notation, that curly bracket means the set of, the collection of everything that comes from n plus 4. So what do they mean, the set of n plus 4? Well, they mean plug in n equals 1, 2, 3, 4, etc. So if you plug in n equals 1, you get 1 plus 4, 5. If you plug in 2, you get 2 plus 4, 6. If you plug in 3, you get 3 plus 4, 7, etc. We're not adding them up or anything like that. We're just listing them with commas. We're just saying it's the collection of all these numbers, 5, 6, 7, etc. forever. That's a dot, dot, dot over here. Dot, dot, dot. Does that make sense? I'm just listing. We're not adding them up now. Does everybody see that? We're just saying the collection of everything you're going to get from the formula n plus 4, but you always start by plugging in 1. Why? That's just what it means to be a sequence. A sequence means start at 1. Plug in 1, plug in 2, plug in 3, and go forever. So if you do that, you're going to get to the formula n plus 4. You're going to get 5, 6, 7, etc., right? So the question is that an arithmetic or geometric or neither sequence? So how do you know if something is arithmetic? So now they're making sure we're clear on this. It's arithmetic if it adds or subtracts the same number each time. It's geometric if it multiplies or divides the same number every time. And if it does neither of those, it's neither. So you tell me, to get from 5 to 6 and 6 to 7, what are you doing every time?
Putting 1, 2.
You're adding 1 every time, aren't you? We're just adding 1 every time, so that's arithmetic. We good? We good there so far? Now the next question is, okay, if it is arithmetic, does it have a common difference or common ratio? How are we doing? Am I losing you guys after an hour and what is it? It's an hour and 40 minutes of talking math at you here. How are we doing? So this is these numbers 5, 6, 7, etc. forever is an arithmetic sequence. It's adding 1 every time. So I would bubble in arithmetic. And then down below they want me to say, okay, so if it is arithmetic, tell me, does it have a common difference or a common ratio? Common difference. Like what's the difference between 6 and 5? 1. What's the difference between 7 and 6? 1. See why it's called a common difference? It's consistently the difference. So we would say common difference is 1. Yeah, so arithmetic sequences, they have the same difference, right? The difference is the second term minus. Remember how for ratio we're taking second term over first term? Because that's a ratio, that's a dividing. For common difference, so this is hearkening back to last night's homework, 12.2. You take second term minus first term. It's a difference, not a ratio. And that would be 1. That's that 1 number that's being added every time. That is the common difference, isn't it? So it's 1. Now down here they say find the sum of the first 50 terms. How do we find the sum of the first 50 terms?
We can use that other formula.
We can use the sum formula from yesterday or from last night's homework from 12.2. The sum of n terms of an arithmetic sequence, the Gauss formula. Remember n over 2, a1 plus an? Remember that formula?
Mm-hmm.
So let me go to a fresh screen and we'll use that thing. Okay, so I'm coming down here. S sub n is going to be n over 2 a1. That's a funny looking a. A1 plus a. Now remember what these terms are. I already listed them. They're 5, 6, 7, right? On and on it goes. Now, here we go. I'm going to use what's n. They want the first 50 terms. So n, remember what n is?
50.
Sorry, I need room. Sorry, I keep changing my mind. I need room. So I'm going to go back. It's number 27. So the formula is n plus 4, which is 5, 6, 7, forever. This is n equals 1, n equals 2, n equals 2. And now we're adding them up, aren't we? So let me put plus signs. We want the sum. What's the 50th term going to be? 54, because you just plug in 50 there. Right? You just plug in the n every time to that formula, right? I plug in 1, 1 plus 4 is 5. Plug in 2, 2 plus 4 is 6, etc. All the way to the 50th term. We're adding up, so the sum of the first 50 terms is n over 2 a1 plus an. So the sum of the first 50 terms. So remember what n is? It's the number of terms. This is the first term and the last term. So the number of terms is 50. The first term is 5, and the last term, 54. So there we go. That's 25 times 59, whatever that is. I don't care. I'm going to move on. 1475? 1475. All right. Make sense on that? We okay on that problem? So I found the sum of the first 50 terms. I took this formula, I just plugged in 1, 2, 3, all the way to 50. Then used the S sub n formula. That's the arithmetic one. Right? That's the one from section 12.2. Last night's homework. Because this is an arithmetic sequence. Why? Because it's adding the same number. Right? Arithmetic is adding, subtracting. You're adding the same number from term to term. I'm going to try that one real quick. So take the 8n squared formula. Plug in 1, plug in 2, plug in 3. Just do 1, 2, 3. That's all you'll need to figure out if it's arithmetic, geometric, or neither. So plug in 1, plug in 2, plug in 3, and see what's happening from term to term. Is it adding the same number? Is it multiplying the same number? I don't know, maybe we will need 4. I don't know. So plug in 1, you get 8 times 1 squared, 8. Plug in 2, you get 8 times 2 squared, 32. Good so far? 5 more minutes, guys. Hang in there. I want to make sure you're comfortable with these last couple things. 8 times 3 squared, 9 times 8, 72. I'll do one more just for fun.
It's not going up with the
8 times 4 squared, some big number, I don't know, 16, 32, 16, 32, 64, 128. It's 128. Anyway, so what's happening from number to number?
neither.
It's neither. Do you see? It's neither adding the same number every time nor multiplying the same. If you thought it was adding, that would be adding what, 16? No. That'd be adding 24. It's not adding 24 because that won't work on the next one. Add 24, you don't get 72. It's not adding the same number every time. Is it multiplying the same number? If so, it'd have to be multiplying by 4. 8 times 4 is 32. But that's not what happens on the next one. 32 times 4 would be 128. That's not right. So it's neither adding the same number every time nor multiplying the same. It's neither. So that means you don't. So down here you'd say there's no common difference or ratio. And then the last part. So try that one. Plug in 1, 2, and 3. And see what you get there. 1, 2, and 3. So plug in 1, 7 to the 1/11th. Plug in 2, 7 to the 2/11ths. Plug in 3, 7 to the 3/11ths. So my question is that arithmetic or geometric or neither? Goes forever. You know, is it arithmetic, geometric, or neither? Is it multiplying by the same number every time or adding the same number every time?
There's a difference, I think, right?
Difference? Is there a common difference?
It goes by the numerator by 1.
It's going up in the numerator by 1/11th every time, right? 1/11th to 2/11th to 3/11th. But that's in the numerator. How do you get powers to add? How if I got x squared and I want the power to go up to x to the third, what do I got to do? Multiply by x to the what? 1. Remember? Powers only add when you multiply. Remember that rule from algebra?
Right.
So that means this is actually a multiply. Right? You've got to take 7 to the 1/11th times 7 to the 1. Then the powers will add and become 2/11ths, huh? And then if you times it by 7 to the 1/11th again, the powers will add and be 3/11ths, won't they? So they're really multiplying by 7 to the 1/11th every time, aren't they? So they're pushing you in your algebra knowledge. This is what calculus does. That's a hard, I mean, you know that, but it's messy here, huh? That's what I mean by calculus pushes algebra. Makes you really know algebra. So they're multiplying by the same number every time here, actually, aren't they? They're timesing by 7 to the, whoops, not 11, 7 to the 1/11th. So that's the R, is 7 to the 1/11th. So this is a what kind of series then? Geometric. And then you got to find the sum of the first 50 terms. So you got to use that messy formula. All right, I'm out of time except for this. With our last minute, we talked about 0.9 bar, which is 0.9's forever. And I claimed, I don't know if you heard me claim, that that's not just close to 1, but it's exactly equal to 1. There's actually no difference between 0.9 bar, 0.9's forever, that being the key word, forever. If you just took 10 million 0.9's, that wouldn't be 1. But if you take them forever, it actually slips into 1.0. It's exactly 1.0. Now, how can I say that? With my last 30 seconds, I'll prove it to you. And when I say I'll prove it to you, I don't mean I'll show you some weird fancy math thing that you can't understand and go, see, I'm right. That wouldn't be any help. I'll show you in a way which you totally agree with, where you are convinced. Let me prove it to you this way. There's a million proofs, but here's probably the simplest one. What's 1/3?
0.3.
You know 1/3, right? What's 1/3? And if you go 1 divided by 3, what's 1/3? 0.3's for how long? Forever, right? We all know that, right? You guys know. I'm not giving you something you don't already know. This is an equation, right? Those two things are equal, not close. 1/3 isn't close to 0.3's forever. It's exactly equal to 0.3's forever, right? So if you take something that's equal and you treat them both the same, the results have to be equal, don't they? Right? You agree with me every step of the way, right? That's what I mean by a proof. So you see what I'm going to do? I'm going to make the left side, if I multiply both sides by 3. What's 3 times 1/3? What happens here? 1. Close to 1 or exactly 1? Exactly. And what's 3 times all those decimals? Isn't it 9's? Forever? See, you're convinced, aren't you? It is true, isn't it? It really is true. It seems bizarre. Like, how does this slip into 1? It does. There's a million other proofs. That's the one that's most clear. We'll stop there.